Hello, my name is Christina Wetzel, and this is my video for Lab Report 1 for Physics 2212. This lab report has three main parts. First, the introduction to the lab, where I'll outline the purpose, principles, and results of the lab, as well as my initial expectations and observations of the first part of the lab. Second, the data gathered. Here I'll analyze the experimental measurements and calculations I took for the second part of the lab, as well as the coding and model for that part of the lab that I've produced. Finally, to the conclusion. Here I'll analyze the data that I collected for the second part of the lab and answer some theoretical questions about the topics this lab covers. This lab had two main parts. The purpose of the first part was to demonstrate the idea of charge, which is a property of matter, by observing the interactions of these U-tapes with other surrounding objects. The purpose of the second part of the lab was to determine the excess charge on one of these U-tapes and also find the number of excess particles, number of atoms, and the electron-to-atom ratio. The main principles used to do this is Newton's second law, net force equals mass times acceleration, and Coulomb's law. These two things will be explained in greater detail in the calculation slide. The overall results for the calculations of the second part of the lab are seen here. For the first part of the experiment, we created charged tape by placing two pieces of tape on top of each other and ripping them apart. The top tape was known as a U-tape, and we created two of them to start the experiment. First, we wanted to see what would happen when they interacted with each other. I predicted that when they interacted with each other, they would repel, as they were created the same way and likely had the same charge. I ended up being correct. In this case, when they interacted with each other, they repelled and formed a V-like shape. They were attracted to their surroundings, however, including a textbook, a lamp, and my hands. When a U-tape was introduced to a negatively charged pen, it had a couple of options. If positively charged, it would attract the pen, and vice versa. Negative would repel. And if it was neutrally charged, it wouldn't interact at all. In this case, they repelled each other, which meant that we found that the U-tape was, in fact, negatively charged. This concluded the first part of the experiment. Now that we know that the charge is negative, we want to compute the magnitude of that charge, and did so using the experiment 2. In this case, we set two repelling U-tapes on top of each other, so the bottom one repelled the top one with its electric force. In this case, Newton's second law comes heavily into play, as the net force is equal to mass times acceleration. Because the top tape is not accelerating at all, we know the net force must be equal to 0. And the fact that there are two y forces acting on the tape, the force of gravity and the electric force of the bottom tape on the top tape, we know now that these two forces must be equal. This plays heavily into our calculations. Additionally, this part of the experiment operated on two assumptions. One was that the two U-tapes had the same charge, which makes sense because they were created about the same way. And second, that each tape was treated as a point charge, where all of its charge was concentrated in the very center. You need this assumption to use Coulomb's law, as Coulomb's law is used for point charges. Using these assumptions and Newton's second law, we did the calculations as shown. You can see in the upper right, all the calculations are there, and an explanation of them is at the bottom. This is the code that I used to model the second part of the experiment. If you pause the video, you can see it uses the same calculations we did handwritten to compute the charge and employs the same two theoretical assumptions, that the tapes are point charges and that they have about the same charge. This function also uses a function from Lab 0 to find the electric field vector and the force vector. This is the model that the code on the previous slide creates. As you can see, the two tapes modeled as two spheres, point charges, the downwards red arrow representing the force of gravity, and the upwards orange arrow representing the electric force from the bottom tape onto the top tape. You can also see that the program has calculated the charge as negative 5.85 times 10 to the negative 9th, which is the same as that we hand calculated. Overall, both the charge and the number of electrons seem to be in a reasonable ratio for the experiment. The ratio itself, because there are so many atoms than electrons, demonstrates the strength of the electric force and how not many electrons need to be present to exert enough of a force to float a tape. For some of the theoretical questions, one was what if electrons had positive charge and protons had negative charge? How would that change the experiment? Overall, both the charge and the number of electrons seem to be in a reasonable ratio for the experiment. The ratio itself, because there are some more many atoms than electrons, demonstrates the strength of the electric force and how not many electrons need to be present to exert enough of a force to float a tape. For some of the theoretical questions, one was, what if electrons had positive charge and protons had negative charge? How would that change the experiment? My answer is that it wouldn't.